Hi, my name is Dorothy, 74626. Today we're going to talk about thermodynamics.
The name of thermodynamics stems from the Greek words therm, which means heat, and dynamics, power, which is most descriptive of the early efforts to convert heat into power. There are three fundamental laws that describe thermodynamics. Let's get into the zeroth law first. Zeroth law states that if two bodies are in thermal equilibrium with a third body, they are also in thermal equilibrium with each other. Now let's get into the first law of thermodynamics. This law applies the conservation of energy, which is one of the thermodynamics properties. It cannot be destroyed nor created, but able to change from one form into another form of energy. Last but not least, the second law of thermodynamics. It asserts that energy has quality as well as quantity, and actual processes occur in the direction of decreasing quality of energy. For an example, if we leave a hot coffee on a table with a room temperature surrounding, it will get cold by itself. But if we replace the hot coffee with the cold one, it will not get hotter by itself. Now we have already understand the basic concepts of thermodynamics. Let us see one of the examples of application area of thermodynamics.
A simple system inside an air conditioner. That is what we're going to use as our example for today's chapter, thermodynamics. So here it consists of compressor, a condenser, an expansion valve with an evaporator with a blower motor. How does it work? So here the compressor then will receive a low pressure, low temperature gas, and then will compress the gas into a high temperature and a high pressure gas. The gas will then flow through this pipe and reach this condenser. As it reaches this condenser, the gas will turn its state from gaseous state to liquid state. This is a condenser, hence the liquid will be condensed. The pressure and temperature will remain high, then it will flow through this pipe and through this expansion valve. Then it will produce a low pressure and low temperature liquid here. It will go to the evaporator, at which point it will boil and turn into a low pressure, low temperature gas as it absorbs heat. So this chills the evaporator box. As it chills, the blower motor will blow out the cool air outside. And as the blower motor blows the cool air outside, the lower pressure and low temperature gases will then return back into this compressor, and it circulates all over again as you turn it on your air conditioner.
Now let's talk about the fundamental of an air conditioner. Basically, an air conditioner transfers heat from indoor to outdoor. Although you may think that an air conditioner creates cold air, they are just extracting heat from indoor and send it outside. Now when the heat is removed, the air is cooled down. It is the best way to think that this whole process is just a heat flowing from indoor to outdoor. Now as you have listened to my explanation on how an air conditioner works,
you can see that all things around us apply thermodynamics. Now, when we understand how thermodynamics works, you can explain to people how does this thing or that thing work scientifically. Thus, we'll help each other to invent something better that can benefit us in our lives together.
Thank you for watching this YouTube video. I hope your understanding in thermodynamics will getting better, and God bless your day.